Indifference curves, the analogy to contour lines. Contour lines are just another example of isolines. In particular, they are what might be called iso-elevation lines. That is, a contour line is simply a line that connects points on the map that are of equal elevation. Let's take a look at an example. The dark bold lines are going to be our contour lines. So for example, the contour line labeled 3600. The points on the map that lie on this particular contour line are all going to have an elevation of precisely 3600 feet. Similarly, if we look at the contour line labeled 3400, all the points on the map that lie on this particular contour line are going to have a height of 3400 feet above sea level. So notice that near the center of the map, there's an X marks there. That's the peak of a mountain, and it's labeled 3813, indicating that the peak is 3813 feet high. Now, even if this peak had not been so marked, we could still have figured out that the peak was going to be somewhere in that innermost contour line. How could we have figured that out? Well, let's see. We could have started from the contour line labeled 3600, and with a bit of work, we could have figured out that each successive contour line adds 40 feet in elevation. Hence, the next contour line must be of elevation 3640, and the next one 3680, 3720, 3760, and finally the innermost contour line is 3800 feet. So we went through the arduous exercise of labeling every single contour line. We could have figured out that this 3800 feet contour line was the highest one. So the peak of the mountain must be somewhere inside this innermost contour line. I'm now going to argue that there is a very close analogy between contour lines on the one hand and indifference curves on the other. In the case of contour lines, which we also refer to as iso-elevation lines, as we move through each successive contour line, we were moving up to an ever higher level of elevation. Analogously, with indifference curves, which we also refer to as iso-preference lines, as we move up each successive indifference curve in the direction of northeast, we are moving to an ever higher level of preference. And this is because northeast is the direction of increasing preferredness. Chris wants to be as far to the northeast as possible. So just like a mountaineer might like to reach the peak of a mountain, or in other words, just like a mountaineer might like to reach the highest level of elevation, analogously, we can think of the goal of Chris the consumer as being that of trying to reach the highest level of preference. Or in other words, we can think of him as trying to scale the highest hedonic peak. Recall that we restated Chris's problem as that of choosing any one feasible consumption bundle. In other words, his problem was that of choosing any bundle in the budget set, which is the red shaded area shown here. We then ask, how was Chris going to go about making this choice, given that there are so many choices to choose from? And now, using the simple example of preference that we introduced earlier, where Chris's preference is simply to try to maximize the total number of fruit that he has, we can actually give a definite answer to this question. Let's now add to the graph Chris's indifference curves. As you will recall, the indifference curves corresponding to this preference look something like this. And now we can restate for the second time the consumer's problem. The consumer's problem is now simply to be on the highest indifference curve without leaving the budget set. As mentioned earlier, northeast is the direction of higher indifference curves. So Chris wants to be on an indifference curve that is as far to the northeast as possible. Now, Chris would certainly like to be on the blue indifference curve because it's furthest northeast. However, this is not possible because it lies outside his budget set. There is no bundle along this blue indifference curve which is feasible or affordable for Chris. Now let's look at the other extreme. Might Chris like to consume somewhere along the black indifference curve? This indifference curve lies in the budget set, so Chris can certainly afford to buy any bundle along this indifference curve. However, why would he do that given that he can buy any bundle along the yellow indifference curve? The yellow indifference curve is also completely within the budget set, and so every bundle along the yellow indifference curve is also affordable or feasible. Yellow indifference curve is moreover higher than the black indifference curve, so there's really no reason for Chris to ever want to consume anywhere along the black indifference curve. So in fact, by inspection of our graph, we can actually figure out that the indifference curve that Chris would choose to be on is the red indifference curve. In particular, the bundle he's going to choose to consume it is the blue bundle. The reason is that this particular bundle is the bundle in the budget set which is on the indifference curve that is furthest to the northeast. There is no other bundle within the budget set, that's the red shaded area, which is on an indifference curve that's further to the northeast. At this point, you should pop out the champagne and congratulate yourself, because you've just solved your first consumer's problem. And what exactly was the consumer's problem again? It was this. Given income, and given the prices of goods, and given a specification of preference, how many apples and bananas should Chris buy? And our solution to this consumer's problem was given precisely by the blue bundle. Chris's solution is to buy 20 apples and 0 bananas. So all we've done here is to solve one very simple example of a consumer's problem. In future videos, we'll see how we can analyze the consumer's problem in a more general setting using similar methods.